Dear students, after studying this module, you shall be able to know the importance of alcohol compounds. Design the synthesis of carbonyl compounds using 1,1 carbon disconnection approach. Understand the synthetic pathways of alcohols using aldehydes or ketones and Grignard reagent. Design the synthesis of carbonyl compounds using 1,2 carbon-carbon disconnection approach. Alcohol compounds are an important class of compounds in organic chemistry, and any compound possessing the group ROH, where R is alkyl group, comes under the category of alcoholic compounds or its derivatives. The different kind of alcohols include primary, secondary and tertiary alcohols as shown here in the figure. Alcohols have wide applicability in our daily life. They are useful as synthetic intermediates, cleansers, cosmetics, fuels, alcoholic beverages, etc. The synthetic and the retrosynthetic analysis of alcoholic compounds are required for their utility. The carbon-carbon disconnections of alcohols are more challenging because of their vast numbers, and it becomes very difficult to identify which carbon-carbon bond to disconnect for carbocation and carbanion. However, there are reagents available for the generation of carbanions like a Grignard reagent RMGX and carbocations like RBR. Synthesis of alcoholic compounds by 1,1 carbon-carbon disconnections. Any compound bearing an alcoholic group can be disconnected at carbon-carbon bond adjacent to oxygen. The starting materials for these types of compounds are an aldehyde or ketone and Grignard reagent. As shown here, it can be seen that how a tertiary alcohol can be produced from a secondary alcoholic carbocation and which can be traced from a ketone. For example, if we look into 2-methyl 2-propanol, it can be made from acetone and methyl magnesium bromide as shown in the structures 4 and 5. Let us look at the retrosynthetic analysis. The retrosynthetic pathway for 2-methyl 2-propanol given by the structure 1 is shown here in the figure. The carbon-carbon bond adjacent to the oxygen has been disconnected to give a cation 2 and an anion 3 as the synthons. The reagent for the cation 2 is acetone and that reagent for the carbanion 3 is a Grignard reagent, which is methyl magnesium bromide. The synthesis, the synthetic pathway of 2-methyl 2-propanol 1 is given in figure. The reaction of methyl bromide with magnesium in the presence of dry ether gives Grignard reagent, methyl magnesium bromide as shown in the structure 5. The reaction of methyl magnesium bromide with acetone gives the target molecule. Synthesis of branched side chain alcohol. Retrosynthetic analysis. The retrosynthetic pathway of the branched side chain alcohol
2,3-dimethylbutane 2-ol-7
is given in the figure. The carbon-carbon bond adjacent to the oxygen has been disconnected to give the cation 8 and the anion 3 as 2 synthons. The reagent for the cation 8 is 3-methyl butane 2-one given by the structure 9, and the reagent for the carbanion 3 is the Grignard reagent methyl magnesium bromide, and the reaction takes place through the path A. An alternative and a more popular is also possible through pathway which is the B pathway. Here the synthetic pathway of
2,3-dimethylbutane 2-ol-7
is given in figure. The structure 5 of the Grignard reagent with the ketone 9 in the presence of dry ether and the acid gives the alcohol as the material which is required. The reaction of methyl bromide with magnesium in the presence of dry ether gives Grignard reagent methyl magnesium bromide. The reaction of methyl magnesium bromide with 3-methyl butane 2-one gives the target molecule. The synthetic method through the pathway B disconnection approach is shown here in the figure 7. Synthesis of unbranched side chain alcohol. Retrosynthetic analysis. The retrosynthetic pathway of the unbranched side chain alcohol 2-methyl pentane 2-ol given by the structure 10 is given in the figures. The two pathways for the disconnection approach have been shown. The pathway B is more favored. The carbon-carbon bond adjacent to the oxygen has been disconnected to give the cation 2 and the anion 12 as the synthon. The reagent for the cation 2 is acetone and the reagent for the carbanion is Grignard reagent. The synthetic pathway of the 2-methyl pentane 2-ol is given in the figure. The reaction of propyl bromide with magnesium in the presence of dry ether gives Grignard reagent propyl magnesium bromide. The reaction of the given Grignard reagent, that is propyl magnesium bromide with acetone, gives the target molecule in the presence of dry ether and the acidic conditions. Synthesis of alcoholic compounds by 1,2 carbon-carbon disconnections. Any compound bearing an alcoholic group can also be disconnected at the carbon-carbon bond next to the adjacent bond to the oxygen atom. The retrosynthetic analysis shows the carbon-carbon disconnection. The starting materials for these type of compounds are epoxide and the Grignard reagent as shown here in the figure. Let us consider an example, 1-phenyl 2-butanol as shown by the structure 14, which can be made from 2-ethyl oxirane 15 and phenyl magnesium bromide. The retrosynthetic analysis of 1-phenyl 2-butanol 14 is given here in the figure. As can be seen that the cleavage of the phenyl and the carbon bond leads to the formation of a phenyl anion, which can be originated from the phenyl magnesium bromide and 2-ethyl oxirane. The ethyl oxirane can be produced from but1-ene. Using the disconnection approach, a synthesis of 1-phenyl 2-butanol as given in the structure 14 and in the figure, the reaction of 1-butene with per acids lead to the formation of epoxide at the position of the double bond known as 2-ethyl oxirane. The reaction of 2-ethyl oxirane with phenyl magnesium bromide gives the target molecule. To summarize, any compounds possessing the group ROH, where R is an alkyl group, comes under the category of alcoholic compounds or its derivatives. The carbon-carbon disconnections are more challenging because of their numbers in the organic molecules. Any compound bearing an alcoholic group can be disconnected at the carbon-carbon bond adjacent to oxygen. 2-methyl 2-propanol can be made from acetone and methyl magnesium bromide. Synthesis of branched side chain and the unbranched side chain alcohols can be explained. Any compound bearing an alcoholic group can also be disconnected at the carbon-carbon bond next to the adjacent bond to the oxygen atom. This is known by 1,2 carbon-carbon disconnection.